It's now time for the Bernard M. Gordon Prize for Innovation in Engineering and Technology Education recipient lecture. The prize, endowed by a generous gift from the Gordon Foundation, is named in honor of NAE member Bernard M. Gordon, former chair of the Neurologica Corporation. This award recognizes innovative education modalities in curricular design, teaching methods, and technology-enabled learning that strengthen students' capabilities and inspire them to become engineering leaders. Half of the $500,000 prize is shared equally by the recipients, and the other half is presented to their university to support the continued advancement of the award-winning program. In January, the NAE announced the winners of the 21st Gordon Prize. It went to Rensselaer Polytechnic Institute professors and NAE members Georges Belfort and Stephen M. Cramer for advancing the state-of-the-art in downstream bioprocessing and educating generations of industry and academic leaders who transformed and grew the biotechnology industry. To address challenges in the rapidly growing and evolving biotechnology industry, Belfort and Cramer developed a unique center of excellence for cutting-edge education and research in downstream bioprocessing. Downstream bioprocessing is a critical technology in the biomanufacturing process where complex biological mixtures are purified and refined into biological products that meet regulatory standards required for medical and biotechnology applications. Belfort and Cramer's educational and research achievements in the downstream bioprocessing space were critical to establishing downstream bioprocessing as a discipline in chemical engineering and in implementing new innovations in the biotechnology industry. The center has significantly advanced the state-of-the-art of downstream bioprocessing and educated multiple generations of industry leaders and academics. Please welcome to the podium Professors Georges S. Belfort and Stephen M. Cramer, who will speak about this exemplary engineering education program.
So this is quite awesome. Got to tell you something. It was unexpected. Truth be told, I personally had no idea our students were so productive. What we're going to do is divide this talk, 25 minutes, in 3 segments. 1, I'm going to give an introduction, an overview. 2, I'm going to show a few slides to tell some of the people here who are not in the field of bioprocessing what this involves and what we teach and what our research is about. And then Professor Cramer, my co-award winner, will finish up and tell you how the context, how the whole thing fits together. So it's wonderful to receive a major engineering prize for the success of our ex-students and ex-postdocs. So I will paraphrase and revise a quote from my longtime friend, Nobel laureate Francis Arnold. I've changed the quote to fit today's presentation. Oh, but by the way, before I continue, I wanted to congratulate Christy Anseth, who I've known for a long time, and tell her we're very proud of you, and it's wonderful to receive such a magnificent award. The Simon Ramo Foundation Award is superb. Congrats. This prize goes to, quote, this is from my modification of Francis Arnold's quote. This prize goes to 2 people which doesn't make sense at all. I say, we tend to put us on a pedestal for the work of so many. So I want to point out that the future belongs to them. The science and engineering belongs to them. It's a big, huge privilege to take a ride with them and with my colleague, Stephen Cramer. So I want to give you just a few critical dates that sort of helped us get this thing going. The first thing is there was no master plan over the last 30 to 40 years. In retrospect, it just happened organically. And I'll try to give you a short synopsis of how it worked. In the 1980s, I decided to move to the dark side. I knew nothing about biology. I heard a lot about biology, but I didn't know what they were talking about until I got into my bed. And at that time, my wife, who's a member of Marlene Belfort, is here as a member of the National Academy of Sciences. And she always used to have these magazines, big, thick proceedings of the National Academy in the bed. And my kidneys always got hit. And I thought to myself, what the hell are in these books? Nature, science, what are they? They're not engineering-type books at that time. Today they are. And so what I did was I immediately started to ask the question about how to purify biological molecules. In 1984, it was a very special year for me. I had been at RPI for about 6 years, and I thought maybe I should get out and see what's going on around the world. So I took a sabbatical, and 3 months with Csaba Horváth at Yale, I met a graduate student called Stephen Cramer. In that same year, I spent 3 months at MIT with Ron Probstein, the youngest full professor in the history of MIT at that time, who basically taught me the importance of fluid mechanics and my basic background of membrane science and engineering. And then I went to Caltech for 3 years to meet the founder of molecular biochemical engineering, Jay Bailey. So I got these inputs in, and I think it helped us think about it. 2 years later, I went to an ACS meeting in Chicago and convinced my friend here to come and interview at RPI, even though he'd accepted an industrial job already. I'm sorry. In 2005 and 2013, and I'm coming back to Bob Langer, who was mentioned earlier. So Bob Langer comes from Albany, where RPI is across the river. And he went to high school there, then he went to Cornell, and then he did his PhD at MIT. And I decided, and I'd known him for many years. And so I asked him if I could come on sabbatical at 2005 and 2013. And in both times, he exposed me to extremely creative, challenging research atmosphere. He always said, go for the jugular, go for the real problem, don't fitz around. And I think that made a very big difference on my career and on us hiring people at RPI in our department to try to find out if they would actually choose or select a really important problem. In 1986 to 2025, we operated, Stephen and I, simultaneous, separate teaching and very both intensive chromatographic and membrane separation classes. These are the workhorses of purification, which we now call, bioprocessing. And it turns out that we kept doing this parallel all the time for 35 years. And suddenly all these students kept going, and PhDs and masters and postdocs. And then we realized, oh my word, they seem to be growing up in this industry. There seems to be some effect going on. So I want to make one very small point. At that time, in 1990s, Europe and other countries in the world did not do molecular. They did mainly processing. And what the two of us have done over these 39 years is we've converted and we have looked at the basic molecular properties and then see how they translate into processes. And that was a unique American approach that did not take place in many other countries. And now they do. And so it makes a very big difference. So I would like to now go to the slides and try to give Stephen some time. So the first slide is just what is the Gordon Prize, and where's my little button I can press here. And so we're talking about approximately 40 years of the two of us. It's quite amazing because, as I said at the very beginning, I had no idea what all these... I didn't keep track of what their success was. So apparently, they've had a hell of a success. So let's have a look at what that success is. So as of 2024, our former students had contributed as engineering leaders in commercializing at least 51 biopharmaceutical drugs, which accounted for 1/3 of the global $460 billion market. That's unbelievable. I just couldn't believe it when we were told this. I didn't get, these are not my numbers, and I'll tell you in a minute where they come from, including 8 of the top-selling drugs last year. So, Jeff Levens, who's on the Bernard Gordon Selection Committee, had to do due diligence with the committee, and he sent us this information. I must say we were a bit shocked, to say the least. So, apparently we helped populate a whole lot of people in an industry which we weren't keeping track of. Although we did keep track in that personally. We had them, and Stephen will show you a beautiful picture of some of him and his students. These are 20 that I selected. You don't look at the names. I want you just to look at the last column. And you can see, you'll notice many of the drug companies that they work in are major US biotechnical companies. But not only that, we also educated people in Austria, India, UK, Japan, France, China. We have ex-students and postdocs in all these places. So it's expanded, and I'm not going to show you the number of academics because I wanted to focus on industry here. But we've also, both of us, have at least 10 or 15 academics here and overseas in Korea and France and Italy and Germany, all working on similar problems and expanding this biotech industry. So I want to thank these students because the Gordon Award is their work. So we had this, we were just told a few minutes ago by Al Romick that we had an affair at RPI in April 16th, I think it says there. And so we took them to our most prized exhibit on campus. It's one of the most beautiful performing arts centers in the nation. And all these people came along to the meeting, and we had them a special tour. So I wanted you just to see some of them. On the left is the Dean of Engineering. Next to him is Alex Dazan, and he's from the foundation, the Gordon Foundation. Next to them are some family and students of ex-students of mine, and then some more students, and then the last 6 are all my current students, all of them working on vaccine production. What we do is we're purifying vaccines that Moderna and BioNTech would like to purify with more purity than they do now. So they've been funding us, and we've been enjoying the work together. Now, one of the problems in a small university that we come from, and after being on sabbatical at Caltech, Yale, MIT, Berkeley, and other places, I realized every 7 years that we need to enrich the environment at RPI. So my wife and I have endowed a lecture series called Life at the Interface of Science and Engineering. This lecture series so far has had 10 speakers. 5 of them have been Nobel Prize winners. 2 of them got their Nobel Prize after they gave our lecture, so there must be some connection. We've just lined up another one for next year, and we're hoping to get more, and we'll still continue this. It's been a major success. The universities, both at UAlbany, which you can see at the bottom, and RPI, Rensselaer, the students have told us that they really love this. So the atmosphere in bio and engineering are connected. All right, so let me just go through. Is there a way I could see the, Derek, can I see the talk on here so I don't have to look over there? Oh, okay, so, but then I have to walk away from here. Well, can you hear me or not?
People online will hear you.
I just want to see it, it's easy. I don't see stuff and I don't hear stuff. Otherwise it's fun. It's like I played tennis once and I said, did the ball go in? And I said I couldn't see it. I said, could you hear me? He said, no, what are you saying? All right, so I just wanted to give you a 2-minute synopsis of who I am. I mean, most of you don't know who we are. And so I have some tools that I use, which are fluid mechanics, particle and transport phenomena. I measure forces, molecular forces between molecules. We've been doing that for 35 years. We were one of the first to do it in PNAS on enzymes. Surface interfacial chemistry is a critical aspect of the interaction of biological molecules with polymers. Protein aggregation got me very interested because the proteins aggregated on membrane. And then I realized that Alzheimer's is the same problem. So we have now a hypothesis on how we want to work. And we've published, thank you very much. And so we are very interested in Alzheimer's also. And then we started with messenger RNA. And all of this we do in silico analysis and really try to model. Chemical engineers like to model stuff, so that's what we do. All right, so the research that we've spent and focused on is molecular separations, downstream purification of proteins and messenger RNA vaccines. We've developed a new class of membranes, modified the membranes, transport inside and outside them. So we've done all the stuff that one should do. We recently found a flaw in all commercial polymer microfiltration membranes. Protein aggregation, as I just mentioned, with Alzheimer's disease, and then messenger RNA vaccines, biofuels, and organic molecules. All right, so what kind of classes do we teach? Downstream bioprocessing, of course, that's what we're here for tonight. Advanced transport phenomena, advanced membrane concepts, molecular separation. This is all the stuff that I don't want to go through all of it. Next, we've published something like over 260 peer-reviewed publications, greater than 20,000 citations, 25 book chapters, 50 unassigned patents. And I have a few hobbies that could classify me. One, I played chess. I used to, at 12, I tied the world champion in he played 45 people and beat 44 except for me. But I have to tell you that it was a strategy when it wasn't a clever one. I was 12 and I thought if I took off all these pieces before he had anything to beat me with, he couldn't beat me. And that's exactly what I did, and so he gave me a tie. I'm a history buff. I love US history. I can't see how one can live in this country and not understand history, otherwise you don't know what all the states are doing. I've recently written a viewpoint on how to hire people for a job, for a faculty position, and I understand the University of Texas is using this procedure. And I also helped solve a problem, 400 years of covering paintings and statues in Europe. They use egg white, and no one knew why. And of course, it's the protein that aggregates, and of course, we all know, or we don't know, it forms amyloids, and it actually reduces the gas transport through it. So we published a paper on that. So I want to just end up by thanking people. First of all, I don't want to miss the first person. If I miss her, I'm in deep trouble. So my wife and distinguished professor at the University of Albany, National Academy of Sciences, the love of my life, who has been my friend and has had the most positive effect on my life and my work of anyone. Marlene and I get along on nearly everything except, now you're all waiting. We cannot agree to this day how to pack a dishwasher. She uses entropy and I use enthalpy. You know what that means? My ex and current students, I'd like to thank them. They truly have been a joy of my life to work with them and collaborators. Dean Shekargadi, my friend and colleague, for arranging the event and for all the other things he's done for me and done for Stephen and I. And my old Gordon Conference friend of over 40 years, National Academy ex-president John Anderson. He and I shared a room 40 years ago, and we always laugh about it. I'd like to thank Al Romick, Deborah Young, for helping us. Deborah, you've been wonderful. Thank you so much for all your help. I also thank the Gordon Prize, especially Bernard Gordon, and the selection committee, Ellen Ochoa. Thank you. Where is she? Somewhere around. Thank you, Ellen. And also our nominator, Professor Greg Stephanopoulos from MIT, who was wonderful to do this, a long time and good friend. And finally, I want to thank Steve Cramer. Thank you, and you're up.
Thanks. Okay. Next slide, please.
Press this button.
Which button?
This one.
Oh, you got it.
Got it.
Thanks.
Yeah.
Okay.
What happened to Lucas Stella?
All right, here we go. So now for something completely different. You know that joke, right? Okay, so basically, I'm going to focus not on anything that my lab does. I'm going to focus on what we did in this particular context. So when I came to RPI after finishing with Chaba Horvath at Yale, downstream processing was in its early days, and it was a critical technology that was being run by chemists. No offense to the chemists. And our intention was to create a center of excellence in this space to meet this urgent need in the industry for new materials, processes, and modeling techniques. So the most important part of this is that we envisioned essentially creating a unique center for educating students trained in the state-of-the-art of downstream processing with a critical combination of skills. So I focus on the combination of skills, and we wanted to do this to help this industry to progress. And I was extremely inspired by General Bostic's talk earlier today, where he said, it's the people we prepare, and that was exactly what we were about. We were about preparing the people while also advancing the state of the art. So this was the combination. And a critical thing of our center was to create this unique relationship with the burgeoning biopharma industry. So what we did is we worked very closely with industrial colleagues to identify the critical needs in downstream processing and the various technologies and modeling tools that we had to teach our students. And so we incorporated ongoing research advances in our labs and in our colleagues' labs in mechanistic modeling, biophysics, high-throughput screening, machine learning, novel bioseparation modes, continuous systems. And we did this, we took all of these advances and brought them directly into these classes and directly into the senior lab experiments. So that was a critical component of this. And in addition to training students at RPI, we also taught many specialty courses around the world to increase the state of knowledge of bioprocessing. And I noticed Charlie Cooney is here today. Congratulations, Charlie. And I've had the pleasure of teaching in his summer course at MIT for many, many years. And we took a multi-scale approach to research and teaching. So a key component of our research and the courses were, as George mentioned before, the molecular basis. It was critical to really understand the fundamental molecular interactions and then to take that all the way to the process scale. And again, to provide our students with a unique skill set that enabled them to solve complex problems in the industry. So the things we taught them were molecular interactions, protein surface properties, novel absorption isotherms, high-throughput screening, novel modes of separation, et cetera, and a lot of those technologies were developed at RPI and then were implemented in our courses and then sent out into the world. So that was really a proud thing we did. Actually, I'm not even moving this forward, am I? I'm sorry about that. Okay. A really critical thing we did, though, was our mentoring, right? So we worked with intention to develop a unique approach to mentoring. So we used, for example, and I learned this from George immediately, whenever you're having a meeting or a class or anything that's involving students, you bring a state-of-the-art latest paper, which is really cutting-edge paper, and you immediately raise the intellectual level of the conversations, right? And we also demonstrated extreme enthusiasm for mentoring our students. We're striving to understand them and to encourage their strengths, But we also worked very closely with each student. RPI is a smaller school. We had the opportunity to have this one-on-one interaction with our students, both in the classroom and in our laboratories, to really mentor them, to help them to develop their creativity and their interpersonal and communication skills. And I firmly believe that this combination of technical and direct interpersonal mentoring was directly impactful in our students' really amazing success when they went out into industry and academia. So here is a list of some of my former students, and some of their current positions, right? And what you can see from this list is that, and this is a relatively small fraction of the people from my lab, but what you can see is they have all risen to very high levels, which has had massive impact on actually contributing to the commercialization of all these biological products. And so, needless to say, I am profoundly proud of all of my former students. And a lot of them came to the party we had at RPI, which was a real good time. Here's a picture of some of my former students meeting with us, at the party, right? And I just want to thank, and with some thanks. I've been a little bit fast because I know we have a little bit of a time constraint here, so hopefully that's okay. I want to first of all thank my wife, Bonnie. So Bonnie is over there, and she's probably taking pictures, right? And Bonnie has been my incredible source of support, strength, and insight for many, many, many decades. And in fact, she works as a mentor at Union College, mentoring students in their spiritual well-being. And I have watched her carefully and incorporated that kind of thinking into helping my students to develop not just technically, but as a human being. And I brought that into my work. Thank all the ex and current students, postdocs, and collaborators. Thank Bernard Gordon for creating this wonderful prize. Thank the Gordon Prize Selection Committee, our nominator, and of course I really want to thank George Belfort, because George is literally the reason I went into academia. I wanted to do entrepreneurial activities in the biotech industry, and he convinced me I should become a professor, and I love it. And so I'm very grateful to him. Let's see, I also want to thank Howard Eisenman, who gave the initial money and was a visionary that biotech would be an important field in chemical engineering. RPI for giving us this amazing center for biotechnology and interdisciplinary studies. Our center has core facilities in a tremendous number of critical technology areas, and all of our students, undergrad, grad, and postdoc, can get trained in every single one of those technologies by the core director, and that also significantly contributed to what we did. So I think I'll stop with that and end with a picture of when we actually got the award, which was back in April. We had a wonderful party. It was a wonderful celebration. And I'm deeply honored to be given this honor, and I'm honored to share this with my good friend and mentor and colleague, George Belfort. Thank you very much.
Congratulations to the new inductees for 2025. Thank you.